Hi, I'm Jeff Morris, and today let's talk about understanding application performance problems. So what does really application performance mean? It's really we call it the holistic measure of how an existing application is behaving in terms of responsiveness to the user, from the desktop, from their mobile device, or the server side of the system, with which that application is interacting. When you look at application performance, some of the measurable KPIs that you can listen for as kind of complaints are you look at uptime, right? Is the application available all the time? Is it crashing? And how frequency, what's the frequency of that? You can look at latency. Everyone hates the spinning wheel, right? It's the time it takes for an application to respond to a request. And databases that take a long time to connect or query an application are often the reason why it's slow. But this also turns out to, create user dissatisfaction, right? Again, no one likes to wait. And, because you can imagine the user is captured at that moment while they're waiting. You're wasting their time. You don't want to, a terribly large queue of activity building up, right? Because then you're wasting lots of people's time. You want to look at average response time. You want to look at error rates. You want to look at requests or concurrency rates against the back end of the system. And this is, usually, it's measuring how many users or connections an application can handle at once. So where does this come from? And, why is, let's say, using a cache important, right? You want to cache data in memory, right? Especially data that's frequently accessed in order to avoid waiting for the hard drive or the disk to return a response, a disk I/O. So if you're able to enjoy, faster reads and writes by just looking at the cache and not going to disk, that's better. You gain better response, more responsiveness for your web application or your mobile app. And you might use fewer resources. You won't have to engage the hard drive, and therefore the bottom line is going to be you're going to enjoy better performance, better user experience, lower costs, and all the way around. That's a much better situation for your application. So let's look at why this happens or where it happens. So when you break down an application, oftentimes it's an application that talks to a database that runs on some kind of infrastructure, sometimes, frequently the cloud kind of thing. So when the application is working and running, it's creating requests to the database and to the infrastructure. And when there's, when things slow down, maybe you don't have enough connection ports, or the queue is getting too big and too long, or the backend doesn't respond fast enough, or it wasn't built for the volume that you're now experiencing. All of these create, basically, create a busy signal in the application that the request can't go through. They can't get to the database, and therefore, ultimately, that's what creates that terrible user experience. That's the bad thing. So what if you could use something like Couchbase or even another software product that can act as an in-memory cache, which means that it'll cache and save common requests that are happening all the time of previous requests. And then when another request is made of the same thing or the same data, it just uses what's in memory and doesn't have to go and touch the disk. So, ultimately, Couchbase, acts as as the backend for the information it needs. And if it doesn't have everything in memory, and it means that you hit the disk less frequently, and therefore you reduce the overall burden on that system. So oftentimes we see customers look at Couchbase to act as this caching vehicle for a backend system. The number one reason why customers purchase Couchbase is for performance, and this is typically the performance that we're talking about. So you could use Capella running, as a cache at the speed of RAM for your application here. But let's look at, the traditional architectures that you might see and, kind of break these things down. So, one architecture number one is the application could write to the cache in the database at the same time if the data is not there. So, you get two simultaneous writes instead of a single one. Or you get two database interactions instead of a single one, where the data would be read from the cache if it's available there. And then if it's not, it's got to be read from the database. So that's what ends up slowing you down if you're operating in both of these particular design patterns. This is what happens when you use an intermediate data, an intermediate service like perhaps Redis or Elasticache, something like that, as a vehicle to be your cache, is you're still operating and interacting with two different systems, and that's inefficient. So let's look at the way Couchbase might do this. Is Couchbase, basically can talk to the application. Every node in the Couchbase cluster can act as a cache. You can access services. You can have multiple applications interacting with a Couchbase cluster. Very, very simple kind of architecture and straightforward architecture. And then Couchbase can store that information directly as it needs. So basically what I'm saying is Couchbase can not only act as the cache, but it can very likely replace the underlying storage system that was the slow thing in the first place. So when we look at what makes Couchbase special in this regard, is every activity that Couchbase performs is an in-memory activity, right? We have what we call our data control plane, which is DCP, control protocol, excuse me, which streams data amongst nodes directly as the activities are happening. And this in-memory streaming happens at millisecond speed. So every node becomes aware of what every other node is doing. Yet each node can be designed to support particular services inside of Couchbase. The data service, for example, is the service that reads and writes data against the disk. The indexing service, of course, acts as your index. The query service is what runs SQL++, our query language, and creates the query for you. We also have full text search service. We have an eventing service. We have analytic services capabilities there as well. Now, what's cool is each of these can also be scaled independently. So you can dedicate 3 nodes to the data service, as I've done here, 1 for indexing, 2 for query, etc. Right? Or you can mix and match that as you need or as your application desires. So data moves very, very freely and is not burdened by disk bottlenecks, right? The disk bottlenecks will happen in the background when Couchbase is actually indeed reading and writing from the disk itself. So what's the impact of slow performance if you're actually engaging your users, perhaps? They might say things like, my application's got to be fast. I got to have very low latency because I have a lot of users and a lot of products. Or my existing application is too slow as a complaint. Users bail out of it, and it's creating all kinds of negative consequences for us. And I don't have time to rewrite the application overall. You also might hear, my application's got to scale in a distributed manner to reduce network latency, be highly available, support fault tolerance, and adhere to geographic regulations. Wait, that's a lot. But you know what? You can do that with Couchbase. So issues that you might experience, you might lose revenue if this is happening. You might have unhappy users. That's a bummer if this is happening. You might get complaints from your operations teams if that's going on. And the impact is, you might be losing business, you might be losing customers, you can't get to new markets fast enough, you're not going to grow as quickly as you might want, or the application just simply breaks because there's not very good error handling built into there either. So ask yourself, are your current database applications meeting these needs, right? Do they think it's fast enough? How do you measure application performance? Can you tell, how your online order system is performing? We want to talk through your service level agreements with your users, right? And what happens if a failure occurs, right? Do you have challenges boosting application performance today? And so think about what you would do there. How are you going to design for that? And have you ever been in a situation where your app crashed, right? Or was down for an extended period of time? How do you explain what did that cost you? Right? And has that happened more than once? If those things are true, then indeed, you might have a system performance problem where your app, swapping out your database or inserting a caching mechanism, in this environment might be really useful for you. So I want to plant a seed in your head in that when I surveyed my customers, more than half of them, 53%, said that they have reduced their overall TCO when they switch to Couchbase, right? So that TCO happens, if you convert to the cloud, you convert your operating expenses into, you convert your CapEx into operating expenses. You can scale independently as you need. You have centralized management if you're, using something like Capella. If you replace both the cache and the backend database, you'll reduce the amount of software licenses you're carrying. You can continue to leverage your existing SQL skill sets. That's great. And you can enjoy better degrees of performance at scale. Now, don't just take my word for it. We've actually independently tested this, and we've tested it, Couchbase, against competitive solutions that do these kind of things. The yellow bar in my workload C here, 100% read, is Couchbase versus Redis, as well as Mongo and Dynamo. But the important one are the red lines and the orange lines. And you can see, you're just operating as a cache reading, Couchbase is very competitive with a pure cache like Redis. But also, we find typically that Couchbase is used in conjunction with Redis. In conjunction, Redis is used in conjunction with things like Mongo, or Elasticache is used in conjunctions with things like DynamoDB. So consider taking one or two of those lines and pitting it against the Couchbase design here, and you'll see still much dramatic performance improvement and simplification of your architecture. So I've talked about this integrated caching capability of Couchbase, but we also have direct key value access to whatever data is stored in the database. We also provide JSON document access. We include ACID transactionality built into the database. We support a SQL query language, SQL++. And then we have all those other services I mentioned: search, analytics, time series data support, eventing. And then our clustering is active-active, so it scales very, very cleanly. We have a really clever feature called the data map, which tells the application exactly where its data is all the time. And all of these things lead to what I like to refer to as why Couchbase is so well differentiated here, right? We're really fast. We're very affordable. The system is incredibly versatile, as I've just described, and it's really as easy as SQL. So the things we've been focusing on here is this memory-first design and the ability to scale your environment very, very cleanly. This is what drives our incredible price performance, and still provides you the versatility of not only being a JSON store with schema flexibility as you might need it, but all 7 of these different data access patterns. And finally, supporting SQL++. It's a language that most people already know if they've ever learned SQL in their lifetime. So enjoy Couchbase quite a bit. As I wind down here, what is the real driver behind this? Well, the reason why Couchbase wins all the time, the #1 reason why customers pick us is performance, then it's scale, and the tunable architecture that we offer. Then they love the flexibility of JSON, and that's what they were seeking. But they also use us and Capella App Services for mobile and IoT deployment, because we have an embeddable mobile client that supports peer-to-peer synchronization. We're as easy as SQL. We support over a dozen SDKs for your favorite programming language. And as I mentioned earlier, we demonstrate low TCO all the time. Just ask my customers like I did. So finally, you can reduce the high cost of operations. You can cut your use of multiple databases at once and eliminate the infrastructure that you might need to be running there. You'll gain higher degrees of performance, which was the original problem we're solving for, but you can save on infrastructure, save on software, save on admin and integration costs. You typically go faster. Your development team can code more efficiently because they're working in a single pool of data and not working with lots of different interfaces. And you can test and deploy this really efficiently as well. So thanks for going through application performance issues and understanding how Couchbase helps address them. And if you want to find out more, keep investigating Couchbase Capella.